Hi, welcome to React Foundation for the Brave Mind. I am Gideon Usani, a front-end web development engineer at Atop Web Technologies. In this tutorial, I will show you the basic ideas behind React. By the end, we will build a small React app so you can see how everything fits together. We will start with a quick setup, what you need to install and how to get ready. Then we'll look at what React is and why many developers love using it to build user interfaces. Next, we will learn how browsers show content on the screen and how JavaScript changes it. After that, we will see how React makes this process easier and cleaner. I will show you, or we will move on to writing React code using JSX and learning how to build UI with components. We'll also learn how to pass data using props and add interactivity with state. Finally, we will connect all the pieces and create a simple React app you can build on later. Let's get started. To get started, you will need to install Node.js. You can do this by visiting nodejs.org. When you are on their site, you would see a step-by-step guide on how to install Node.js. Once Node.js is installed, verify your setup by running the following command. Firstly, node-v to confirm that Node has been installed on your PC. So you would need a package manager known as npm. We have several package managers like PNP, Yarn, but in this case we are using the npm. So you would run the npm-v. If you get a version number, your environment is ready. Nextly, we are going to be creating a new Vite plus React app. And in order to do this, we are going to run the following command: npm create Vite at latest. To get a full tutorial on how to do this, you could visit the React plus Vite website and you would have a breakdown or run through on how to go about this installation. After installation is done, navigate into your project. In this case, the name of my project is my app, and install dependencies by running npm install. This command syncs your project dependencies, activating the foundation for your next digital experience. Finally, start your development server by running the command npm run dev. Your workspace is now live, fast, reactive, and ready for innovation. So now that we have our environment all set and running, we are moving on to what is React. React is a library for building interactive user interfaces. But hold on, what exactly is a user interface or UI? A UI is everything you see, touch when you use a digital product. By digital products, we mean things like your social media apps, your banking app, and all that. It is what lets you talk to your computer or your favorite app. Imagine you open Instagram or you visit our Atop website. The buttons you tap, the pictures you scroll through, the boxes where you type your comments, those are all parts of the user interface. You can think of the UI like the controls on a car. The steering wheels, the pedals help you interact with the car, just like your UI helps you interact with a website or an app. So, React helps developers build those user interfaces, the part of an app that users actually see and use. One of React's greatest strengths is focus on components. If you are new to using libraries and you're most likely coming from the HTML and CSS, you realize that for each time you want to make a button, you have to build that button from scratch and everything from scratch. But what React helps you, one of its strengths is your ability to build components. You can imagine components to be like a building where you have, for instance, 12 rooms, right? In HTML and CSS, imagine building that house from HTML and CSS. You have to build these 12 rooms from scratch. But in React, all you have to do is build one room, and then whenever you want to build, let's say, a 12 by 12 room again, all you just have to do is take that room and place it somewhere else. That's what we call components. It's just reusable. React components are reusable, right? So developers create these components once and they use them anywhere in the app, making development faster, code easier to manage, and interfaces more consistent. To help developers build these components, React uses something called JSX. JSX stands for JavaScript XML. It is a syntax extension that lets you write HTML-like code directly inside your JavaScript file. It is not HTML itself, but a powerful, concise way to describe what the UI should look like, right? For example, instead of complex JavaScript calls to create an element, a developer can just write simple tags like button, right? And once you remember we talked about creating your component. So whenever you want, after you've done everything, whenever you want to use that button again, all you just have to do is call it. Then the button will appear on your web page and light up when it is clicked. With React, developers can create these reusable building blocks like buttons, forms, menus, and they come alive when you interact with them. So in short, React is a tool that helps developers build the things you click, type, scroll through quickly, beautifully, and interactively. React focuses on components and uses GSX, and that's one of the greatest power of React. There are more to what you can do with React, like props, state management, and a lot more. But in this tutorial, we are just going to be summarizing this, but we are going to see more as we go further. So now that we know what React is, a JavaScript library for building user interfaces, let's take a step back and understand how browsers actually create those interfaces in the first place. To understand how React works, we need a basic understanding of how browsers interpret our code to create or render our user interface. When a user visits the web page, the server returns an HTML file to the browser that may look like this. The browser then reads the HTML and constructs the document object model. Now that brings the question, what is the DOM, right? The DOM is an object representation of the HTML elements you have on your code. It acts as a bridge between your code and the user interface and has a tree-like structure with parents-child relationship, as you can see on the screen. Imagine you are building a house. Now this is how the DOM actually works. Imagine you are building a house. You start with a blueprint. Now that's your HTML code. It is a static plan on paper, like your building plan, your architectural drawings, right? Are like just a static plan on paper. You have sketches of where your wall is supposed to be, where your windows are supposed to be, and all that. But in this case, the browser cannot interact with that paper. Like the browser cannot interact directly with your HTML. The browser doesn't have it's not able to interact directly with that your HTML. So it needs something that it can work with. So now your browser takes, in this case, for instance, your HTML, or still using the analogy of your plan, right? It takes that blueprint and builds a 3D digital model of the house. A 3D digital model is the DOM, right? The live version of your HTML inside the browser. Just remember, we say your browser cannot work directly with your HTML file. So now it has to create a representation of that HTML, which is the DOM. You can now manipulate things using the DOM, right? Now this is where JavaScript comes in, right? It allows you to walk around the digital house and make real-time changes without rebuilding the whole thing from scratch. You can use the DOM, you can use DOM methods and JavaScript to listen for user events and manipulate the DOM by selecting, adding, updating, deleting specific elements in the user interface. DOM manipulation allows you not only to target specific elements but also to change their style and content. In the next section, you will learn how we use JavaScript and DOM methods. In this section, we're going to be talking about updating UI with JavaScript. We'll start building out our project by using JavaScript and DOM methods to add an H1 tag to your project. We are going to be opening up our VS Code editor and we are going to create a new index of HTML file. Inside this HTML file, we are going to add some codes. We already have our HTML file set up. I'm going to be explaining to you step by step how this is done. Alright, let's look at how our browsers actually build what we see on the screen. Here we have a simple HTML file and inside of it we will use JavaScript to add some text. What we are going to be seeing on our screen when we are done is a simple hello world. First of all, we have created a div and we give it an attribute of ID and passed in the value of app. We created our script tag and also gave it an attribute of type and passed in the value of text/JavaScript. We are going to be writing our JavaScript inside the script tag. So firstly, this line tells the browser, hey, go find the element in the HTML that has the ID named app. In this case, it is the empty div we created. Now we have a reference to that div stored in a variable called app. So you could think of it like finding a specific box, right, in your room that is labeled app. Now we know where to put things. We know our target div. So the next line here, we create a brand new HTML element and H1 heading using JavaScript. At this point, it only exists in the memory and it's not on the web page yet. So you can also imagine this, that we built a signboard that says heading, but you haven't placed it anywhere yet. Next, we create the actual text that we want to show inside our H1 tag. In this case, hello world, we store it inside something called a text node, which is just the text contents ready to go inside an element. Think of this as writing words on your signboard before you hang it up. Now we attach the text node to our H1 element. This means our heading now contains the text. You have just stuck the paper with your words onto the signboard. Finally, we place the entire H1 element with the text inside it into the div called app. This is when the content actually appears on the web page. Now, take your finished signboard, hang it up on the wall so everyone can see. So the final output we are going to see when we go live is hello world. Now you will see a big bold heading called hello world because that's how the H1 tag works by default. So let's check it out. So as you can see here, we have our hello world displayed here. So now this takes us to HTML versus DOM. If you look at the DOM element inside your browser developer tools, you will notice the DOM includes the H1 element. The DOM of the page is different from the source code, or in other words, the original HTML we created. So if you look at this HTML file here that we created, you just see an empty div with an ID. But if we go ahead to inspect our hello world text or the DOM, we are going to see that it displays differently. Here, if we inspect our hello world, we are going to see that our H1 here, we have a H1 here that carries the text hello world. We have a div here that contains the hello world in between. However, on our HTML, that which is our source code, we just have this, right? So here we have the hello world. I'm going to zoom that for a bit so you could see it more clearly. So you could see that this is different from what we have in our source code. So you might be wondering why that is. This is because the HTML represents the initial page content, whereas the DOM represents the updated page content which was changed by the JavaScript code you wrote. Updating the DOM with plain JavaScript is very powerful but verbose. We wrote a bunch of code just to add the H1 element with some text. As the size of an app or a team grows, it can become increasingly challenging to build applications this way. With this approach, developers spend a lot of time writing instructions to tell the computer how it should do things. But wouldn't it be nice to describe what you want to show and let the computer figure out how to update the DOM? Now this is going to lead us to imperative versus declarative programming. The code we wrote earlier is a good example of imperative programming. You are writing the steps for how the user interface should be updated. But when it comes to building user interfaces, a declarative approach is often preferred because it can speed up the development process. Instead of having to write DOM methods, it could be helpful if developers were able to declare what they want to show, in this case a H1 tag with some text. In other words, imperative programming is like giving a chef step-by-step instructions on how to make a pizza, whereas declarative programming is like ordering a pizza without bothering or caring about how that pizza is being prepared. React is a popular declarative library that can build user interfaces. So React as a declarative user interface library, as a developer, you can tell React what you want to happen to the user interface, and React will figure out the steps of how to update the DOM on your behalf. In the next section, we will explore how you can get started with React. In the last section, we told the browser exactly what to build. We saw how to use our JavaScript to update our UI. We told the browser exactly how to build our signboard, create a header, create the text, stick the text into the header, then stick the header onto the wall. That's called imperative programming. In this section, we are going to be looking at getting started with React. Now we are going to switch to React. We will start by loading two scripts, React, the core library, and React DOM, part that talks to the browser for us. First, we use the React DOM library to create a root. We tell React, the box in the room, the one labeled app, like we have here, is where you are in charge now. This establishes a connection point where React can add the UI. Going to the analogy in the previous section, we are now handing over control of the billboard labeled app to a dedicated contractor named React. From now on, you only talk to the contractor. You don't need to go through the process of doing things yourself. Next, we use the root.render to tell React what we want the final UI to look like. Notice the line, "Hello world, this is React." This is called declarative programming. Instead of telling the contractor every step, make a sign, write the words, hang the sign, we simply declare the final state. I want an H1 sign that says, "Hello world, this is React." However, when we run this code, the browser throws an error, uncaught syntax error, expected expression, token. This is the error we are going to get. I'll just zoom that in a little. So why are we getting this error? This is because H1 is not a valid JavaScript. This piece of code is JSX. You can imagine that you wrote the design request right from the construction instruction, but the browser only understands plain JavaScript blueprints. It sees the symbol and gets confused because that's HTML syntax and not JavaScript. Remember in our introduction phase, we talked about JavaScript creating a DOM. It doesn't understand the code you're writing directly to it. It now creates something like a blueprint, which is your DOM, and that is what it understands. So now this leads us to introducing GSX and Babel. The problem is the H1 tag inside the JavaScript. The HTML-like syntax is called JSX, JavaScript XML. It is a powerful tool for describing UI, but browsers don't understand it naturally. What is JSX? JSX is a syntax expression for JavaScript that allows you to describe your UI in a familiar HTML-like syntax. The nice thing about JSX is that apart from following 3 JSX rules, you don't need to learn any new symbol or syntax outside HTML and JavaScript. But browsers don't understand JSX out of the box. You will need a JavaScript compiler such as Babel to transform your JSX code into regular JavaScript. To fix this, we would need a translator, Babel. So we are going to go back to our code and introduce yet another link, which is the Babel. This is our translator, and then we are going to add this. If we check this now on our browser, we are going to see it displayed. We load the Babel script, and crucially, we change the script tag type to text/JSX. This tells Babel translate everything inside the script block into standard JavaScript before the browser runs it. Now, we compare these 3 lines of code we just wrote with our previous 9 lines of code. That's the power of React. We write declarative JSX describing the final UI state. Babel translates the JSX into plain JavaScript. React DOM handles the tedious step-by-step DOM manipulation, creating elements, appending text on your behalf. In short, React is a powerful library that acts as your efficient UI contractor, automating the entire process of updating document object model. In this section, we are going to be looking at building UI with components. 3 core concepts of React that we will need to be familiar with to build or to start building our React application. These are components, props, and states. We will go through these concepts and make sure you are familiar with them. We are going to start with components. These are components, props, and states. We will go through these concepts and make sure you are familiar with them. We are going to start with components. Components are user interface. One, two, three. User interfaces can be broken down into smaller building blocks called components. Components allow you to build self-contained reusable snippets of code. If you think of components as Lego bricks, you can take these individual blocks and combine them together to form large structures. If you need to update a piece of the UI, you can update a specific component or a brick. You could imagine a house whereby you have your rooms, parlors, and all built separately, and then when you put together these rooms, parlors, your toilets, it forms the whole building. And whenever you need to detach something from it, here's pictorial view of how components primarily work. So in this picture, we have the media component, we have the image, we have the text, we have a button, and when you put all this together, it forms a page. This modality allows your code to be more maintainable as it grows because you can add, update, and delete components without touching the rest of your application. The nice thing about React components is that they are just JavaScript. Let's see how you can write a React component from a JavaScript perspective. In React, components are functions inside your script tag. We are going to create a function called header. So still building on our previous code, we are going to create our function. We are going to create a function called header. A component is a function that returns UI elements. Inside the return statement of the function, you can write JSX. So inside our function, we are going to write JSX. So we are going to still write hello world. So to render this component to the DOM, we are going to pass it as the first argument in the root.render method. So we are going to pass this here. But if we actually check this out in our, if we check this out when we go live, we are going to have an error, right? But to make this to work, there are two things we need to do. So you can see here, the error says warning, functions are not valid as a React child, but you're going to get primary an error here. But to fix this error, there are two things we have to do. Firstly, first React components should be capitalized to distinguish them from plain HTML. First of all, we are going to capitalize the H here and here as well. Then nextly, the second thing we are going to do is you use React component the same way you would use a regular HTML tag with the angle brackets. So we are going to call this header like we would call a HTML tag. We had a little issue there. We did not return this. So yeah, now we can see the issue has been resolved. So if we check this out in our browser, we are going to see that hello world, this is React, would be displayed on our screen. So also we could take it a step further by nesting components. Applications usually include more content than a single component. You can nest React components inside each other like you would regular HTML elements. In our example, we are going to create a component called homepage. So here we have our component called homepage. So we've created our component homepage. Then we are going to nest header inside that component of homepage. Inside here, we are going to we'll just move this up a bit. Then inside here, we are going to call header. Now that we have nested this header, in React, you can keep nesting components this way to form a component tree. Here's an example of how a component tree works. So from what we are building, you have the home page here, right? So we have header, article, and footer nested under the home page. Then under the header, we have our logo, title, and nav. So all these are basically components that are nested inside the header. And then we have the link. Let's say this is your home, about, and your services page, all nested inside the nav component. So you could keep nesting components as we go. Project, since homepage is now our top level component, we are going to pass it to root.render. So instead of having the header here, we are going to pass homepage here. So if we go and check this out, we are going to see, let's just change the text or add something into it. And you can see, voila, we have that. So we nested, just to recap, first of all, we created our header component, which we said is a function that returned this, and then we then created our home page, and we returned header, and then nested, called it inside the root.render. So in this section, we are going to be looking at displaying data with props, and we're going to be building on what we have done so far. If you were to reuse the header component, you will display the same content both times. I'm just going to make a little change here. If you check your browser, you will see that hello world, this is React, this is our homepage, repeated twice. But what if you want to pass different text, or you don't know the information ahead of time because you are fetching data from an external source, right? Regular HTML elements have attributes that you can use to pass piece of information that change the behavior of those elements. For example, changing the source attribute on an image element changes the image that is shown. Changing the href attribute on an a tag changes the destination of the link, like where if you click the link. So if you initially had, for instance, locally slash home, if you click that button, it is going to take you to the home page. And when you change that to maybe slash about, clicking that same button takes you to about, right? In the same way, you can pass piece of information as properties to React components. They are called props. Take for instance the possible variation of these buttons. From these buttons, you can see here the primary button has a blue overlay, and here it doesn't have, it's a secondary button, and here the button is disabled. What enables us to do this is what we call props. So what is props? Props are arguments passed into React components. Props are passed to components via HTML attributes. Props, the word props that we have been using stands for properties, just short for properties. React components are like function arguments in JavaScript and attributes in HTML. To send props into a component, we are going to be using the same syntax as HTML attributes. So similar to JavaScript function, you can design components that accept custom arguments, or what we call props, that change the behavior or what is visibly shown when it is rendered on the screen. Then you can pass down these properties from parent components to child components. So we are going to be looking at using props. So in our home page, we are going to pass a custom title prop to the header component, just like you did pass a HTML attribute. Same way you pass an attribute and the value, that's the same way we are going to pass this. In the header, the child component can accept the props as its first function parameter. So this is what we mean. In our header, we are going to pass inside here props. If we console log props, you can see that an object with a little property is going to show. So let's just console log this. If we inspect, we are going to see an object here. I'll zoom in. So you can see the title here as we have here. So we passed here title React. So when we console log this, have React. Since props is an object, you can use object destructuring to explicitly name the value of props inside the function parameters. So this is what we are. Instead of passing props, you could just use brackets and then pass here title. Then you can replace the contents of the h1 with the title variable. But we are just going to look at this. We are going to change this as well to title, and then we are going to look at it in our browser. If you look at this, you see that React is just passed here directly, right? We did not, the title is not showing, right? It's just React that's passed here directly. So we can even take this even further. Then you can replace the contents of the h1 with your title variable. So inside our header, instead of having this text here, you can just pass title. But we are going to have an issue. What is going to display here is just going to be the text title. If you open the file in our browser, you see that what is actually displaying there is just the word title. This is because React thinks that we are intending to render a plain text string to the DOM. So we need a way to tell React that this is a JavaScript variable that we are trying to pass. So this is what leads us to using variables in JSX. To use the title props, we are going to add curly braces. These are special characters, or these are a special JSX syntax that allows you to write regular JavaScript directly inside your JSX markup. So this title that we pass here, we are going to pass curly braces around it. You can think of curly braces as a way to enter JavaScript land while you are in JSX land. You can add any JavaScript expression, something that evaluates a single value inside a curly braces. We are going to be going through several examples of how you can pass props. So we are going to look at an object property with dot notation. So you can see that here we are passing props.title. Inside this function, we are supposed to be returning JSX, but with our curly brackets, we can escape that and write JavaScript using the dot notation. So we could also use template literals. So you can see we are not using our regular quotation marks. So we are using template literals. So if we look at this in our browser, we are going to see that it is going to display cool, and then whatever we pass here, we are going to see cool and react, just as we have here displayed. You can see we have cool react. We have more examples of what we can do with the curly brackets, escaping GSX and being able to pass in React. We can pass ternary operators. We can also pass ternary here. So how this works is that we are telling that the title should be tied to whatever we pass here, or if there's nothing passed here, the default text should be default title. But since we've passed React, we are going to see React. If we take off this, or we are going to see the default text, default title. You can now pass any string to your title props, or if you use the ternary operator, you could even not pass a title props at all. Since you have accounted for the default case, your component can now accept any generic title props. Components can now accept any generic title prop which you can reuse in different parts of your application. All you need is to change the title string, just like we have here. So you remember what happened earlier when we passed the header, it gave us the same text multiple times. So if we go to our browser, we are going to see React. If we pass another title here, we are going to see React and a new title. And then if we just pass here header, we are going to see our default title. So you see, from one component we have been able to display several text or title. In this section, we are going to be looking at adding interactivity with states. We are going to explore how React helps us add interactivity with states and event handlers. So we are going to be looking at examples. Our first example, we are going to start by creating a button. We are going to make the button do something when it is clicked, and to do that we are going to add the onClick event. In React, event names are camel cased. The onClick event is one of the many possible events you can use to respond to user interaction. For example, you can use onChange for input fields or onSubmit for forms. You can define a function to handle events whenever they are triggered. We are going to create a function before the return statement. Then you can call the handleClick function when the onClick event is triggered. If we run this on our browser, when we click the button, we are going to see on our console log this text increments like count. So if we click the like button, we can see increments like count displays in our console. If we click it again, it shows that we've clicked it twice. This leads us to states and hooks. React has a set of functions called hooks. Hooks allow you to add additional logic such as states to your components. You can think of states as any information in your UI that changes over time, usually triggered by user interaction. Like just like the examples you can see on your screen. So the original state of this button is on, and on click the state changes to off. Same here, looking at this example, the original state here is 221 likes, and then after several clicks it becomes 666. You can use states to store and increment the number of times a user clicked the like button. In fact, the React hook used to manage states is called useState. We are going to add useState to our project. It returns an array, and we can access and use those array values inside our components using array destructuring. The first item in the array is the state value, which you can name anything. It is recommended you name it something descriptive. The second item in the array is a function to update the value. You can name the update function anything, but it's common to prefix it with set followed by the name of the state variable you are updating. You can also take the opportunity to add the initial value of likes state to 0. Then you can check the initial state is working by using the state variable inside your components. We are going to check that this shows on our browser. So you can see that the original state here is the default state here is 0. Finally, you can call your state updater function set likes in your home page component. Let's add it inside the handle click function we previously created. Now, if you go to our browser and click the button, it will call the handle click function, which calls the set like state updater function with a single argument on the current number of likes plus 1. As you can see, as we click, it's incrementing. This is just an introduction to state, and there's more you can learn about managing states and data flow in React application.